Ever looked up at the night sky and wondered about the deepest mysteries it holds? Out there, in the vast, silent expanse of space, lurk some of the most enigmatic and powerful objects in the entire universe. What are black holes? They sound like something straight out of science fiction, but they are very real. Imagine a place in space-time where gravity is so strong, so incredibly intense, that nothing, not even light, can escape its grasp. It's a point of no return, a cosmic enigma that challenges our understanding of reality itself. Today, we're going on a journey to the edge of the universe and back to unravel the secrets of these celestial monsters. How are they born? What makes them tick? And what happens if you get too close? Stick around, because we're about to dive deep into the heart of a black hole. So, where do these cosmic behemoths come from? The story of a black hole begins with the life and death of a truly massive star. Not just any star, but one many, many times larger than our own sun. Throughout its life, which can last for millions of years, this star is a brilliant celestial furnace. In its core, a constant battle rages on. The immense force of gravity tries to crush the star inward, while the explosive energy from nuclear fusion pushes outward. This delicate balance is what keeps the star stable, shining brightly in the cosmos. But all stars eventually run out of fuel. For these massive stars, the end is not a quiet fade into darkness. It's a spectacular, violent event called a supernova. When the fuel is gone, gravity wins the war. The star's core collapses in on itself in a fraction of a second. This catastrophic collapse triggers an unimaginable explosion, one of the most powerful events in the universe. The star's outer layers are blasted into space, creating a beautiful, expanding cloud of gas and dust. But what about the core left behind? If the original star was massive enough, its core continues to collapse under its own relentless gravity. It shrinks and shrinks, packing more and more mass into an ever smaller space. It crushes itself down past the point of being a neutron star, squeezing all that matter into a point of infinite density. This infinitely small, infinitely dense point is called a singularity. And around this singularity, a black hole is born. It's the ghost of a star, a gravitational shadow left behind, so powerful that it warps the very fabric of spacetime around it. Now that we know how they're born, let's explore the anatomy of a black hole. One of the most famous features is the event horizon. You can think of it as the black hole's boundary, the ultimate point of no return. It's not a physical surface you could touch, but rather an invisible border in space. Once you cross the event horizon, the escape velocity, the speed you need to escape the black hole's gravity, becomes greater than the speed of light. Since nothing in the universe can travel faster than light, anything that crosses this boundary is trapped forever. It's a one-way trip into the unknown. But black holes aren't just invisible voids. Often, they are surrounded by a spectacular display of light and energy. This is called the accretion disk. As gas, dust, and even entire stars get too close to a black hole, they don't just fall straight in. Instead, they get caught in its gravitational pull and begin to spiral inward, like water going down a drain. As all this material swirls around the black hole, it gets compressed and heated to millions of degrees. The friction between particles becomes so intense that the matter glows brilliantly, emitting powerful radiation, including X-rays. This accretion disk can be one of the brightest objects in the universe, ironically making the black hole itself, which is completely dark, visible to our telescopes. We can't see the black hole, but we can see the fireworks happening right at its edge before all that matter takes its final plunge, crossing the event horizon and disappearing from our observable universe forever. One of the most mind-bending ideas about black holes comes from Albert Einstein's theory of general relativity. Einstein showed us that gravity isn't a force in the traditional sense, but a curvature of spacetime caused by mass and energy. Imagine spacetime as a flat, stretchy rubber sheet. If you place a bowling ball on it, the sheet will bend and curve around the ball. This is what massive objects like stars and planets do to spacetime. Now, imagine taking that bowling ball and squeezing it down to the size of a marble. It has the same mass, but it's concentrated in a tiny point. The dent it would make in the rubber sheet would be incredibly deep and steep. This is exactly what a black hole does. Its immense mass, packed into an infinitely small singularity, creates a bottomless pit in the fabric of spacetime. This extreme warping of spacetime has profound effects on everything around it. Light, which normally travels in a straight line, will have its path bent as it passes near a black hole. This phenomenon is called gravitational lensing. If a black hole passes between us and a distant star, the light from that star will be bent around the black hole, and we might see the star appear in multiple places at once or as a distorted ring of light. This isn't just a theory. Astronomers have observed this effect many times, providing powerful evidence for Einstein's ideas and the existence of black holes. They literally bend the path of light, distorting our view of the cosmos. So, are black holes just cosmic vacuum cleaners, sucking up everything in the universe? It's a common misconception, but the answer is no. A black hole's gravity is only extreme when you get very, very close to its event horizon. If we were to magically replace our sun with a black hole of the exact same mass, something amazing would happen: almost nothing. Earth and the other planets would continue to orbit it just as they do now. We would freeze in the darkness, of course, but we wouldn't be suddenly sucked in. You have to get incredibly close to a black hole to be captured by its gravity. They don't roam the universe hunting for planets and stars. Instead, they are a fundamental and crucial part of how the universe works. They play a vital role in the evolution of galaxies. Supermassive black holes, millions or even billions of times the mass of our Sun, are found at the center of nearly every large galaxy, including our own Milky Way. Their immense gravity helps to hold the galaxy together, and the energy released by their accretion disks can influence star formation across vast cosmic distances. Black holes are not just objects of destruction, they are also engines of creation and order. They are cosmic laboratories that push the laws of physics to their absolute limits. By studying them, scientists hope to unlock some of the deepest secrets of the universe, from the nature of gravity to the ultimate fate of the cosmos. They are not just celestial oddities, they are key to understanding our place in the grand, cosmic story. Thank you so much for joining me on this incredible journey to the edge of reality. The universe is filled with wonders, and black holes are surely among the most mind-blowing. If you found this as fascinating as I do, don't forget to hit that like button and subscribe to the channel for more deep dives into the mysteries of space. What cosmic topic should we explore next? Let me know in the comments below. Until next time, keep looking up.